Welcome to the Lantern Light AI Newscast number 26. Brains Chips and the Future Firing Up. Made by Chris Morley, in Boston on Tuesday, May 12, 2026 at 11:14 p.m. UTC. Silicon chips are pushing brain-computer interfaces closer to your skull and your living room, as a new minimally invasive BCI design makes headlines and Neurable pivots to licensing its technology for everyday wearables. Meanwhile, the AI world is racing to build its own custom chips while researchers discover that language models organize information much like the human brain itself. Fusion energy is drawing fierce global competition, and inside classrooms AI tools are already reshaping how students learn, though not everyone is getting an equal share of the benefits. Starting today's program, a look at invasive brain-computer interfaces. Researchers at Columbia University, Stanford University, and the University of Pennsylvania have developed a new brain-computer interface that uses a single silicon chip to create a wireless, high-bandwidth connection between the brain and an external computer. The device can be implanted through a minimally invasive procedure and has already been used in more than 50 patients. Separately, scientists at the Chinese Academy of Sciences, working with Huashan Hospital and Fudan University, announced their own advances in invasive BCI technology in late 2025. Both developments point to growing momentum in a field aimed at helping people who have lost the ability to move or speak. Now, a story from the world of nuclear fusion power. More than 50 startups across the United States, Europe, China, and Australia are now competing to be the first to deliver nuclear fusion power to an electricity grid. Commonwealth Fusion Systems moved closer to that goal this week with a fresh milestone in its effort to bring fusion onto the U.S. grid. Meanwhile, Pacific Fusion announced it is seeking researchers to run experiments at a new pulsed power inertial fusion facility planned for New Mexico. China has also set an ambitious target to reach fusion power by 2030, marking what analysts described as a significant shift toward a truly global race for what could become a clean and virtually limitless energy source. Now, a story from the world of AI hardware chip design. A startup called Cognichip announced in April 2026 that it is building a deep learning model designed to work alongside engineers as they design new computer chips, aiming to speed up a process that has taken the industry decades to refine. The move reflects a broader shift in the technology sector, where major cloud providers including Google, Amazon, and Microsoft are developing their own custom silicon rather than relying solely on off-the-shelf processors. OpenAI formalized a chip partnership with Broadcom, one of the most closely watched hardware deals of recent years. Analysts say the push toward custom chips is being driven by the soaring computing demands of large artificial intelligence models. Moving on to our next item. A new study published in 2026 found that large language models organize meaning in ways that closely parallel the human brain's so-called semantic hub, a region long believed to unify knowledge across different senses and concepts. Researchers say the findings suggest that some cognitive structures emerge naturally from learning on large amounts of language data, rather than from biological evolution alone. The work adds weight to ongoing efforts to build computational models of cognition that can both explain brain function and improve artificial intelligence. Scientists caution that similarities between neural networks and biological brains do not mean the two systems are identical in how they actually process information. Next, another item from across research and industry. Artificial intelligence is spreading across school systems worldwide, but costs vary enormously depending on how institutions choose to deploy it. Simple AI tools that help teachers plan lessons can run as little as $25 a month, while larger adaptive learning platforms can cost tens of thousands of dollars, creating real access gaps between well-funded and under-resourced schools. UNESCO has been urging member states to adopt AI in education guided by principles of inclusion and equity, warning that poorly managed rollouts could deepen existing inequalities. A systematic literature review published in 2024 found growing research interest in how AI shapes learning outcomes, though many questions about long-term effectiveness remain open. Last up for today, Boston-based startup Neurable announced a pivot to a licensing platform model, opening its non-invasive brain-computer interface technology to consumer wearable makers across multiple industries. The company uses EEG sensors and AI algorithms to capture and analyze neural signals, offering insights into cognitive performance without any surgical procedure. By licensing the technology rather than building finished products, Neurable aims to lower the barrier for enterprise and consumer adoption significantly. Separately, Santa Barbara firm Cognition has been expanding access to its Axon R wearable neural interface platform through a partnership with implantable BCI developer BlackRock Neurotech, targeting research applications. Today's program is brought to you by Lantern Light AI. Please note that Chris Morley is a seasoned software architect currently available for inquiries seeking help using AI to build, run and maintain modern web applications, cloud systems, databases, streaming data pipelines, search engines, interactive 3D graphics as well as other high-performance software services at scale. If the avatar or the newscast format interests you and you would like to see something like this customized for your business use case, please email Chris Morley at chris.morley@lanternlight.ai. If you enjoyed this, like, subscribe and share with your friends. More science, tech and AI news coming soon. Thanks for watching.